Hello once again, and welcome to the next installment of Networks and Decision-Making Maths. All right, today specifically, we're going to be looking at some flow problems. All right, let's start off with a scenario, a bit of background. Okay, as you can see here, there are 10 pieces of raw material delivered to 2 factories. On a normal day, 5 go to each factory. By the end of the day, each factory produces 5 items ready for sale. So we can show that on a network diagram. So if we start with 10 pieces here, 5 go off to factory A, 5 go off to factory B, factory A makes 5, factory B makes 5, and then at the end of it, there's 10 pieces come back out, which is perfect. All right. Now then one day, one of the factory B machines breaks down, leaving only 4 items that could be made. So what's happened here? Factory B, one machine broke down. It's turned into a 4. They've only produced 4 items. Now all up, there's 9, only 9. So something's not efficient. Now we have a process using the flow diagrams and networks that we can use to demonstrate this. We do this by using what's called cuts through the diagram or digraph. It's a weighted directed graph or digraph to help find the maximum capacity of the network. So in other words, if 10 items come in, what's the maximum number that can come out? All right. There's a cut. So what we do, we look at the value of that cut. 5 plus 5 is 10. Then we look at this side. 5 plus 4 is 9. So you can see somewhere along here, somewhere between there and there is a drop of 1. All right, that's a very simplistic version, but let's go through it and see what actually happens. First up, we're going to look at the parts of a flow diagram, as you can see over here on my right. Now, we'll label bits. So we need to know where the source is. The source is where everything originates. So the way to pick that is have a look at these arrows here. Every arrow in this network is coming out of this point. So that is our source. The other point we need to find is the sink. Okay, that's over here. This is the point where all the arrows converge. Okay, it's just like a sink. Imagine some water. All your taps come in here, go into the sink, go into the basin, and then down the sink. Okay, it works the same way. So all the arrows converge on that point and go down the sink. So that's the output. The other bit you'll notice are these numbers on the lines. These are the weights. Okay, better known in this case as flow capacity. Now that depends on what you're measuring. It could be time. It could be volume, for example, volume of a liquid. It could be the number of things, a physical number, like a number of buses or something like that, or a number of taxis. Okay. Just need to keep that in mind when you're doing the problem. Now, another way to think about it is, let's imagine we've got some pipes, as you can see down below me here. Okay. We've got a big pipe around the outside. A little explanation I'll go through in a minute. Big pipe down here, which you can see. But if we've got a smaller pipe that goes into it, and this is what's containing all the fluid, liquid, whatever you've got, then there's no way you can get any more than that pipe down through the big pipe, is there? So you're constrained by what goes in through there, despite how big this is. All right. Have a look it up on this diagram here. Our input, we've got 20 plus 30 is 50. On this side, on the sink side, we've got 20 plus 70, which is 90. We've got 50 going in, but possible 90 coming out. We can't make any more in this diagram. We've only got a maximum of 50 that can possibly get through. That's what's happening here. The smaller pipe going in to a bigger pipe, that's a wasted pipe up there, isn't it? Only needs to be this big. So what we're trying to find is, as it says here, we're trying to find the maximum amount of stuff, whatever it is, time, volume, number of things, whatever, we can get through the network at any one time. this is going to be the minimum sized pipe. Okay, let's get a little more mathsy. All right, minimum cut equals maximum flow. So that's what we're aiming for. So we use these cuts, which we talked about, to cut through the network to determine the potential flow at that point. All right, so our ultimate goal is, just below me here, to find the smallest cut capacity through the network. Okay, this shows the maximum possible flow through the network, which we just talked about. Now, there are some steps involved here. So let's have a look at these. So first step, identify the source and the sink. Well, let's have a look at this diagram over here. Arrow coming out, arrow coming out. So obviously this is going to be our source. Let's see where these arrows go. They're all going this way. So this is obviously going to be our sink. Next step, always, please, do your first cut around the source. So over here, let's do a cut. We'll draw a line and we need to add the values of this cut. So we've got 20, we've got 30, and that adds to 50. Now, what we might do is might keep a running total just down here. The minimum cut so far is 50. Not a total. We'll find out what the minimum is. Okay, second step, around the sink. So here's the sink. We'll do a cut around here. So we've got 25 there and 70. 25 plus 70 is 95. Now notice this minimum cut hasn't changed because 95 is bigger than 50. So we want the smaller number or smallest number when we get to more of them. All right, third step. We need to make some more cuts between the minimum, between the sink and the source. And we want to do at least 3 of them really. Now, this last point, only count edges that point from the source to the sink. Don't worry about that one so much right now. We'll talk about that in a minute. So let's put some more cuts in the middle here. Here's one, straight through the middle. We've got 30 there, 10 there. 30 plus 10 is 40. Well, you can see 40 is going to be less. So 40 is less than 50. So we've changed that. All right, next cut. Over here, 25 up here, 10 there, it's 35, less again, even better. Now let's see if we can put one over through here. 20 there and 10 there, 20 plus 10, beautiful, that's 30, that's even less. Now there are more we could do here. There could be put one through here, the 20, and go through the 70, but that'd be pretty pointless because that's 90 again. You can see if we drew one straight through there, that would add up to 90. So it's not going to be any less than 30. All right, so it looks like our maximum flow through this network is going to be 30. The minimum cut's 30, so the maximum flow is 30. Now, I've written units down here because there weren't any units on this graph. If you have a graph with units, make sure you put it, be it meters, be it liters, be it whatever it is, okay? All right, where do you put the cuts in the middle? Good question. We have to be a little bit scientific about this. So we've got our source cut, we've got our sink cut. Let's just pretend they're out of the way. This is just about where to put the cuts in the middle. All right, we need to completely separate the source from the sink so that no flow can occur. So just imagine we're cutting the pipes completely and we're blocking it off. And we're going to measure where those pipes are cut. All right, let's have a look. Get rid of those two. And let's put one down here, for example. Now, does this one cut off the source and the sink? Well, it's pretty straightforward. You can see, no, it doesn't. I can still go along this track, along up here, and along down here. All right. Sometimes I like to do something which is get a piece of paper, if I've got a spare piece of paper, and I'll lay that over one side of that cut. So let's bring up a piece of paper, and sometimes it just helps you see where things are. All right, so let's try it again. Nope, 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 definitely can't go there. This one's even worse than that because you could go down here as well and through. So it's not going to help us, is it? It doesn't completely separate the source and the sink. Okay. So that's a big red cross on that one. No good. All right, let's have a look at another one. Right there. Let's see. There's our line. It looks like it cuts it. We'll put our paper back, so this might help a bit easy, make it a bit easier to see. It's cutting there. It's cutting there. I can't get through that cut. So that's a good one. All right. Where else could we do one? Why not here? Absolutely. Through the first one, down through these two. We'll bring our paper back up. Let's check. We've cut that one up there. Now see how I keep it over this side? I can see where my arrows come. And this arrow is fine. Doesn't go anywhere near the cut. This one goes from the source to the sink. That's fine. This one goes from the source to the sink. That's fine as well. So that's a good cut. All right, let's look at one more. Straight through here. Hang on, we might get rid of this dodgy cut down here first. There we go, make it easy to see. This cut, let's see. Bring our paper up. That's going through, that's good. That doesn't make it, that doesn't make it. This one is going from source to sink, that's great. But have a look at this one. We've completely cut off the sink. That's no problem, it's completely cut. I can't get anything through there. But this is a special case, this arrow here. All right, it's a good cut, but we remember that bottom tag we had on the last slide, only count the edge weights that go through your cut from source to sink. This is what's happening. So when we add this one up, what we want to do is we want to use that one because that one arrow goes from source into the sink. See the arrow's pointing through it. See this line here? That's going the right way from source to sink. But this one is going the wrong way. From that starts in the sink, goes up and comes back out. So we don't count this arrow. So when we're adding them up, when we do our weights, which we'll go into more detail again in a second, we go the 10 down there, we don't include the 5, and we do include the 20. So the 10 there plus the 20 is 30. That would give us our weight for that one. All right, let's have a look at some examples. Or one example anyway. Okay, determine the maximum flow rate in litres per minute. So it's obviously about a pipe. There's a liquid going down a set of pipes between S and T on the diagram just there. Okay, so first up, well, let's get these instructions back. First up, identify the source and the sink. All right, so arrow, arrow, correct. There's the source. Where are they going to? Identify the sink, arrow out, out, out. Yep, that one's the sink. Now, most of the time, it'll go left to right. Be careful though, look at the arrows carefully. Sometimes it goes top down. Sometimes it goes bottom up. Okay, look at the arrows carefully. All right, next step. First cut around the source. Well, here we go, around the source. There we go. And what does that one add up to? Let's see, 8 there, 11 there's 19. Great. Now I've labeled this one cut 1 rather than write a total over here. So cut 1 is 19. Second step, cut around the sink. So there's the cut around the sink. Cut 2, the 3 there, the 5 there, the 1, which equals 9. Great. Let's put some in the middle now. Okay, now let's see. Let's try it without a paper first up. That arrow goes through there, that's fine. Source to sink. That one goes, obviously, source to sink. And this one, yep, definitely goes source to sink. So let's see. That one's pretty straightforward. We can see 8 plus 3 plus 1 is 12. Great. That's our second lowest. Cut 2. So we've only got a maximum of 9 so far we can get out. Less than 12, less than 19. It could be more. There's plenty of lines in there. Let's have a look. Where will we go now? Let's go through here. All righty. Now we're getting a little more interesting. Oh, look at that arrow there. It's going backwards, isn't it? Okay, so just to make sure, let's put the paper there so we can see. All right, so that one's going the right way. So we'll circle that one. I like to circle. Sometimes it makes it easier to see. This one here starts in the wrong side, doesn't it? You can see it's in the shaded area. So we're not going to count that flow. This one here, now obviously the paper doesn't match up, but it's about that line going through the cut. Yes, it starts on the correct side, on the source side. So we'll count that one. And this one, again, obviously starts in the right part, in the source side. So we'll count that one. So that is going to be 3, not that. So 3 plus 3 plus 1. 3 plus 3 plus 1, what's that? That's 7. Awesome. That's even less. Well, it's not necessarily awesome. That's worse because we've got 19 coming in and we're down to 7 already. That's not great. All right, let's have a look for some more. Now we've got this big area here. What about if we cut through here? Let's see. I'll try that way first. Let's try this one. Okay, bring our paper back up. It's looking a bit messy. So that one's going the correct way. Yes. This one's not going the correct way. And this one is going the correct way. So let's see, 3 plus 11 is 14. Okay, is what it is. Now we'll try one through this big gap area here. Now, good idea. Put plenty of cuts, 3 minimum, but the more cuts you can do, the more accurate you're going to be. Oh, this is looking a bit ugly, this one. Okay, so let's have a look up here. Try and do it without. So what's that? That's going the right way, that one there. Okay, so we'll include that. This is getting a bit hard to see in through here, isn't it? So we'll put our paper back. So that, see, now that's going the right way, even though it looks like it's going backwards. Okay, so again, really good idea. Put the paper there, makes it much easier to see. I'm starting on the source side, the unshaded side. So we do need to include that one. This one here is going the right way, fantastic. And this one here is going the right way. So all 4, even though it potentially looked like that one wasn't. It feels like it's going backwards, but it's not. So 8 plus 5 plus 5 plus 1 is 19. Okay, this is a word of problem. So we can say that our lowest cut, our minimum cut is 7. And therefore, we'll put it back in terms of the question, the maximum flow rate between S and T is 7 litres per minute. All right, answer the question. Please be careful with this, all right? Think logically. It's all about source to sink. Put your cuts at the start, the end, and then do some cuts through the middle. If you can use something that goes backwards, absolutely feel free to go use something that goes backwards because it doesn't count in the total. All right, be methodical. Good luck with it.